In this video, I'm going to explain everything you need to know for the SAT about triangle similarity. I'm going to explain what triangle similarity means, how to tell whether a triangle is similar to another one, and also how to solve some of these harder triangle similarity problems when you do see them on the test. If you want to know why you should trust me, I've personally scored a 1550 on the SAT. I currently own the largest SAT Skool community on the internet, and my goal is to make the channel that you're watching right now the best SAT YouTube channel in the entire world. Okay, as for triangle similarity, here's what you need to know. Basically, the way you can think about this is, let's say you have two identical twins. I have met a few identical twins in my life. And if you have identical twins, people who look exactly the same as each other, have the exact same genetic information for the most part as each other, these people would basically be equivalent to congruent shapes. There are two shapes that are the exact same thing. So if I draw one square and just go ahead and literally copy that square over, these two squares would be congruent to each other. They are literally the exact same shape in every single regard. But what if one of these identical twins did something to really change how they look? I guess let's be real. What if one of them got a lot bigger than they were at first? So much bigger guy. I'm not saying there's anything wrong with being bigger, but let's just say they got bigger for whatever reason. Now these twins would not be congruent because one is clearly a lot different than the other one. They would be similar. They have the same overall genetic makeup, but one is just literally bigger than the other one. And that's literally how similar triangles work. There are two triangles that are the same in every single way, except one is just literally bigger than the other one. So what this is going to mean is that their side measurements are going to be proportional to each other. So not the exact same, but based around the same ratio. So for example, we see here 4 and 3. This one here is 6, and 6 is twice as much as 3, so therefore this one up here for x must be twice as much as 4. And that's why you to solve it here, and twice as much as 4 would be equal to, of course, 8. So that's how it works. You take every single thing from the first sides, and then you multiply it by a set number, and that's how you get these sides for all the bigger triangle. And this is exactly how every similar triangle situation works. The other thing you should know, though, is that the angles are going to be the exact same. So if this angle over here were to be 60 degrees, this one over here would also have to be 60 degrees. For the angles, it's the exact same, whereas for the sides, you just multiply each one by the same exact thing. Now, as for how you can use this in problems, you can write it into a proportion format like here. 3 over 6 is equal to 4 over x. So we have here 3 and then 6. So matching those up between the triangle is equal to 4 over x. So again, matching those up. You have to make sure that you match up exactly which ones correspond to which. And I'll talk more about how to do that in a second. In this scenario, you can just put this in there. If you want to, you could put it into Desmos and you would find that the answer would be x equal to 8. I also want to just quickly mention that you can also write the ratio slightly differently. If you want, you could have just said 4 divided by 3 is equal to x divided by 6. This would just basically be taking two things from the same triangle, 4 over 3, and then just matching up two things on the second one. So you could also just go ahead and do this. No real difference. It's still going to give you 8 for the answer. So don't worry about that. You can still do that if you want to. Okay, how can we actually prove that stuff is similar? With the example with the twins, if these people were to actually take a DNA test, they would see that yes, they are identical twins. They are exactly the same in how they look, all that different stuff. How can we do the same kind of thing for a set of triangles? Well, there are basically 3 different ways to do it. You can use side, 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 aka all the sides are proportional to the other one. You can do side, angle, side, meaning that two sides are proportional and the angle between those are the exact same. So for example, it would be something like this for them. Or it can be angle, angle. So that just means that two angles are exactly the same. So maybe this one is exactly the same, and also this one would be the exact same on both triangles. A couple things with this. First of all, you probably have seen many YouTube videos talk about this exact thing before, and you may have heard slightly different rules for this. You may have heard somebody say something like angle, angle side, or something like that. I'm not including that just because it literally doesn't matter. If I just say angle, angle, that embodies everything that has two angles in it. It's going to be the same no matter what. Likewise, you cannot do angle, side, and then another side. This will just not work for a host of different reasons I don't want to get into. But yeah, it couldn't be the case that you just have one angle over here, and then you have the two sides that are like this one and that one. They have to be sides on each side of that angle itself, like this and that. So this would not work, not a valid way. The rest, though, are perfectly fine, and you can definitely use them to prove that triangles are similar to each other. They're like a valid DNA test. Okay, so I'm going to show you some examples. The thing you should know is that whenever you're doing a problem like this, the first thing you should do is set up a visual thing so you can very clearly see which sides are similar to which. You'll see me doing this on every single problem here. The big thing to know is if you're not actually drawing the triangles out in a way that makes sense, it's always going to be very, very confusing and very, very difficult, and you're probably going to be making a lot of mistakes. So try to do that as much as you can, actually write out the stuff shown. So for this one here, we have two triangular planes. We have first of all P, Q, R, and then the second one would be S, T, U. Note here, it says that they are congruent. So like with the identical twins example, that would mean they are literally the exact same, not even bigger than the other one. So just literally the exact same triangle, but it should work overall the same because they would, again, have the same angle measurements. So that's the important thing that matters. Okay, so it says here the measure of angle P is 37 degrees. So that'd be 37. And then says the measure of angle T would be 92 degrees. How would you find the measure of angle R over here? Well, the thing to know with this is that since they are congruent, you just know that this angle over here must also be 92 degrees. Because again, that's just how congruency works. It's the same as if they were similar. They would have the same exact angles in the same places. And then if you've watched my other videos, you would know that for a triangle, it must have 180 degrees as the total angles added together. So I can do 180 minus 92 minus 37, and that gives me 51 as the answer. So therefore, R must be equal to 51. Okay, that was good. Let's get it a little bit harder now. So it says here triangle JKL is similar to MNP. It also says that there's going to be a right angle in both of them, so it'll be something like this. It says the sine of J would be equal to 5 divided by 13. So what this basically saying is opposite for J would be this, and then the hypotenuse for that would be this. If you're confused about what I just did there, you can go ahead and watch my other video on right triangles I just posted a few days ago. Okay, so this is what's going on here, and if you also watch that video, you would know that you must actually put these as a ratio. So we don't know that's exactly 5 and exactly 13, we just know that those are the proportion for them. Probably not going to matter for this problem, but just so you know, just so you're not confused and stuff. It then says that MN is equal to 39, so this would be 39. Then what is the length of NP? So I'm just going to go ahead and make this very easy for us. We have here 13 over 5, so that would be the proportion there. And then it says 39 over NP. So if we were to set it up in similar triangle format, we could say equals 39 divided by, let's just say N for that. Using that information, we see that N must be 15, so therefore this would be 15. If that does not make sense to you, just try to look at this until it does. You're taking here these two sides over here that match up to these two sides over here. You can just set an equation like this. I'm just using this regression to make it a bit easier, but I could also just go ahead and do that and make this x there. And then you use that to see where the answer ends up being. That is the answer for the side measurement. Moving on, sometimes you see problems where you have to actually prove that they're similar. So this is kind of geometry type stuff where you have different pieces of information given to you and you have to actually think to yourself, what would make this true? Not just what to do, how would this even be true in the first place? So it says here triangles PQR and STU. So I'm going to go ahead and draw those. Okay, done. P and S are both 40 degrees. It says PR is equal to 6 down here, and then SU would be equal to 15 over here. Is then asking us what piece of information would be necessary to prove that PQR is similar to triangle STU. Well, remember the similarity rules I just went over here? It has to be side, 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 angle, or angle, angle. Out of those, the only one we could realistically do is side, angle, side, because we have an angle here, a side. Obviously, let's just add one more side. And remember the rule, it can't be angle, side, side, so it cannot be this one. So we can just completely eliminate TU and QR from what we're thinking about here. It's all about PQ and ST. It has to be the sides on either side of the angle. Okay, so looking at this, we're trying to find places where that would be the case. QR, so that would be the one that we cannot use, so therefore A is automatically out. PQ is equal to 8, it says, and then ST would be equal to 20. That seems pretty good, but you can also see here that C says the exact same thing, PQ and ST. And also probably not none of above because we do have enough information here. So it has to be between B or C. The way we can decide between these is just thinking to ourselves the ratios. It says here 6 divided by 15, so 6 divided by 15, 0.4. So we have to have a measurement where it would also equal 0.4 for that thing. So 8 divided by 20, yes, it would be 0.4, so therefore B must be the right answer. If we were to go ahead and try C real quick, 8 divided by 16 would end up being 0.5, not 0.4, so this would not follow similarity rules. Question 4 here, I know this is going to look really complicated, but it's actually not even that bad. Most of this stuff is just information. So let's go ahead and write this here. We're talking about a canyon here, so Grand Canyon type stuff. Lengths are AB, EB, BD, and CD. So AB would be 1500, EB would end up being 1200, BD would end up being 600, and CD would end up being 700. They say they intersect at B, obviously, and they have the same angle measurement here and over here, which would be the value of X, which by the way is just A to E. So in case you're confused on that, that's what X is. So kind of obvious based off the fact that I'm including this in this video, but yes, these would be similar triangles. But if you just want to make sure, just think about it for a second. We have this angle over here, which according to geometry rules would be the exact same as each other because they're crisscrossing right here. So we have the same angle measurement there, but also we have the same angle measurement over here. So we naturally follow that angle rule. Since their two angles are the exact same, nothing else even really matters. So therefore we just know that they must be similar. Okay. This is where it really helps to write out some extra information because yes, this does work, but it's kind of confusing. You have to kind of like tilt your head. You have to like contort your brain to figure out what is going on here. It's a lot easier if I just go ahead and write it right side up. So if I'm writing these triangles, I could say A, B, and then E. So basically this one turned on, making AE the bottom of it. And X would be over here, and then we have 1500 over here, and then 1200 over here. Then we have another one over here. Let me just write the information for that one. Okay, so we have everything. And you can see now, while this would have been really confusing if we were to look at it like this, now that I've positioned it right, it's not that bad. So now we can just go ahead and just literally use similar triangle stuff here. So we're trying to see what is the value of X. We have here 1200 in X and 600 and 700. Let's just go ahead and write proportion with that. So 1200 divided by X1, we can say, equal to 600 divided by 700. So therefore, we're getting 1400 for X, and yes, that would be the right answer. Writing the triangles in an easier to look at way is really helpful for these problems, honestly. Next one here, we have a triangle where point D is there. Okay, yeah, just gives us all the information here again, so you don't really need to read that. It's saying, what is the length of E to C? Again, I'm including in this video, so you can probably tell at this point, these would be similar triangles, but if you want to prove it yet again, you can just look at, if we separate the triangles into this smaller one, and then this bigger one, would they be similar? Well, they have the same angle over here for A, obviously, the same angle both times. And also, if we think about it, according to geometry rules again, since we have these two lines that are both parallel to each other, as they say here, we know that this angle must equal the same thing as that angle. Again, that's just like a small geometry rule. I'll probably try and make another video talking more about that. But yeah, just something you can know. If they both are parallel, you have something like this, they must be the same angle. Angle rules yet again, so therefore they must be similar. So we know they're similar now. Let's go ahead and actually write the thing for it. So what you can just go ahead and do in this situation is write 9 divided by 12 and then is equal to 6 divided by x1. That is a completely valid way of doing this problem. I will say though that just to be absolutely certain, I would recommend doing it more in the case 9 divided by 12 is equal to 6 plus 9 divided by this, just to be absolutely sure, because that wouldn't technically be right according to the rules. Like, this thing here would not be a whole triangle, that's just like a trapezoid. So just one small thing to think about, but otherwise, it's going to give you the exact same answer. So 20, it says there, 20, if that is equal to this entire thing, and we have 12 already, then this would just be 8, as we saw there before. So therefore, the answer would be 8, of course. One more quick example. So we have a 5-foot-tall student that casts a 4-foot shadow, so something like this. And I know it's not really a full triangle, but yeah, let's just pretend like it is. So just write a imaginary line there. And then we have another thing that casts a shadow that is 68 feet long. So a lot longer over here. And we're trying to see here, what is the height of that? So we could say X for that. So not exactly a triangle like I said before, but you could just use the exact same stuff here. So 5 divided by 4 would be equal to x1 divided by 68. Therefore, the tower must be 85 high. A couple things I just want to quickly show you guys before we end off today. Here are two very common similar triangle arrangements you will see on the SAT. If you see anything exactly like either these two things, you just know automatically that they are going to be similar triangles. For this one over here, you can think about it like this. This triangle would be similar to this triangle, which would be similar to the whole bigger triangle as well. So they're basically 3 different similar triangles here. I don't really want to go through the time to prove it, but yes, if you look at the angles, you will find that they are the same angles, and that makes it work. Okay, so this would be a set of similar triangles. Likewise, this is another example of that problem I just showed before. You have this exact angle that would be the same on both this smaller triangle and the bigger one. Likewise, since these lines would be parallel, at least hopefully they would be, you would have the same angle measurement there and there. So 2 similar triangles here, and then 3 over here. I just want to go ahead and solve this problem real quick because this is like a quirky, interesting problem you can see, and solving of similar triangles. Not the easiest way to go about doing it. If you watch my right triangles video, you'll see a much easier way with the altitude rules, but it's just a good exercise to practice doing it. So if you do see something like this and you, for some reason, cannot use altitudes, you could use this instead. Okay, so let's go ahead and start by writing out all the different similar triangles here. This will take a second, but trust me, it'll be worth it, and you don't have to wait for it because I'm going to edit this out. Okay, here are the 3 different similar triangles you can see here. So this one over here would be the one on the left, this one would be this one over here, and this one would be the bigger one if you look at everything all together. Just honestly take a second to think, does this make sense? This is something that's really, really confusing for most students when I show it to them for the first time. Like, genuinely, a lot of students look at this and they're like, I have no idea what's going on here. So genuinely pause the video and just make sure you understand what's going on here. It is exactly what I just said, but you may have to just like look at it for a second to really think about what's going on. Because basically I take this triangle, just use it regularly, and then this one I kind of just like flip it over that way, and then this one over here, it's like I completely like flip it out of the page into it. So that is what's going on here, but those would be the 3 similar triangles here. Another way you can just go ahead and think about this is the size of each side. So we basically have a smaller side here and a smaller side here based on these individual triangles. Then you have a longer side for this one over here and a longer side for this one over here, again with each of these respectively. And then for the big one, you have a smaller side here for the base of the entire thing and a longer side here for the entire thing as well. So just another way to think about it. Hopefully you get it by now though. So at this point, we have almost everything we need for the problem. The one thing I'll just do real quick is, since we have 2 different side measurements here, we can go ahead and use the Pythagorean theorem on that. So 6 squared plus 8 square that as well equals c squared. So we know that this big one must as well be 10. You'll see why that's important in a second. In fact, right now, because we can set a proportion here. 8 divided by 10 would be equal to W for WY divided by 6. And there's how we get 4.8, which would in fact be the measurement of this, and therefore would be the answer for this problem. So similar triangles rule the day yet again, though I will say for this problem, there was an easier way to solve with altitudes. Check my other video if you want to see that. And just remember this, I already showed an example, so not really any need here. One last thing I just want to quickly show you guys before we end off this video. This is something a lot of people really don't include in this stuff, but I think it is important because you could see a problem like this. Is what is known as the angle bisector theorem. So if you have a format like this, you know that AB over AD would be equal to BC over DC. Let me just explain what's going on here. It is not that just if you see a format like this, they must be similar. That's not what I'm saying here. I'm saying specifically if you have a bisector as the line here, this would be the case. When I say bisector, I mean a line that separates an angle into 2 of the exact same angle. So we have here 45 degrees and 45 degrees. Since that's literally the case, then you can use this formula. If these were different things, like if this one was only 30 degrees, you could not use this formula, would not work, would give you the wrong answer. So just keep that in mind. If it is exactly like this, you can go ahead and use this formula. Speaking of which, here's a problem like that. So I'm just going to go ahead and solve this really easily. So 12 divided by 8 equals 18 divided by x1. DC would be equal to 12. Yes, that is the answer. I'm just going to go ahead and teach this as a rule. So you don't need to know really the reasoning behind this. Just know if there is a bisector, you can use this exact way to solve it. As always, if your score is currently below a 1400 and you're trying to push it up there before your next SAT, I would definitely recommend checking out Mission 1400 Plus with the link in the description below. You'll have the chance to ask me any question you want about any SAT topic, plus you get my full math course and full reading and writing course that covers everything on the SAT. We have a ton of people in here all trying to improve their score, and we have a bunch of really awesome perks you can see down here as well. Would definitely recommend, and there's no risk at all because there's a free trial that you can currently access over here. All right, guys, good luck on the SAT, and make sure to always stay Gucci.